Hi folks, welcome back to the fourth and final video for 7.1 Law of Sine. So this last video is just going to be one example where we talk about an application for Law of Sine. So right triangles are all fine and good, but I think a lot of times in a real application, we're not looking at cases where it is a right triangle, all right? So what that means is we can use this law of sines and law of cosines way more frequently than we can with just a basic SOHCAHTOA kind of situation, all right? So let's take a look at this problem. When the angle of elevation of the sun is 64 degrees, a telephone pole that is tilted, unfortunately, and probably a little concerning, at an angle of 9 degrees directly away from the sun, casts a shadow of 21 feet long on level ground. Approximate the length of the pole. Okay, so I'm going to go ahead and sketch this triangle right next to it, and then we'll do our work below. So if I were to draw this triangle, I know I have this part, all right? I know I've got this part, and then I've got this level ground over here. Okay, now what information do I have? Well, I know that this angle is 64 degrees, and let me just go ahead and label this as A and B and C, okay? And I know that this distance down here is 21 feet. And then weirdly enough, they give me that if I had a telephone pole that was standing straight up, then this piece would have been 9 degrees. But what that allows me to do is figure out that angle C is actually 81 degrees, because if the pole were standing straight up, it would be a 90-degree angle. And 90 degrees minus our 9 degrees will give me 81 degrees, okay? Now, I look at this and I say, well, this is great. This is actually a case where I can find all three angles, all right? Because I know that 64 and 81 are only two of the angles, and then that must make B 35 degrees to give me a triangle with 180 degrees inside. Okay, so now let's zoom back out and set up our law of sine. So sine of 64 over little a equals sine of 81 over little c, which equals sine of 35 over 21. Okay, now it doesn't have to be in order like A, B, and C. It could be any of the orders. That part doesn't really matter. But do I have a full pair here? No. Do I have a full pair here? No. But do I have a full pair here? Yes. Okay? Now, and that's because I did the extra work in advance to find that third angle so that I could have a full pair. Okay? You can do that work in whatever order you want, but just make sure that you remember that 180 degrees is how many angles or how many degrees are inside of a triangle. Okay? So it looks like we can go ahead and find out where our little a is, because our little a is going to be this distance or the length of the pole. Okay? So I'm going to say sine of 64 over little a equals sine 35 over 21. And now what we have here, if I cross multiply, is a sine 35 equals 21 sine 64. And I'm going to go ahead and divide. So I'll get a equals 21 sine 64 over sine 35. And when I turn that into a decimal, I get 32.907 feet. And since they're only looking for approximate length of the pole, you could say that A is about 33 feet tall. Okay? Now, because we're looking at a diagram here, we can also tell like which case is this? Is it a angle side, side angle side, side angle? Which one is it? And so when we look at the information that we used, we can sort of figure that out. So I had angle A, all right, and then I used angle B, and then I used this 21 over here. So this is not a side angle case, all right, but it is an angle side, and that will always only give you one answer. Okay, this only gives you one answer, so you don't need to worry about the ambiguous case if you choose one that will give you only one answer. Okay? So before we finish this up, I'm going to scroll back to the top so we can look at the cases and then talk about which ones have ambiguous cases and which ones don't. So scrolling. All right. We started off here with angle side angle. That one will only give you one answer, okay? And then we looked at angle side, which is like the telephone problem we did just now. Angle side will also only give you one triangle. The ambiguous case, though, that is the pain in the SSA, all right? Anytime you see side angle, then you possibly have two triangles, you could have no triangles, or you could have one triangle, right? So the ambiguous case is the only one that you need to consider. How many triangles am I going to get? Okay? And so that wraps it up for 7.1. And if you have any questions, send me an email or a message on Canvas, and I'm happy to help you out. All right, thanks so much, folks.